Okay, so here are a few questions with angles and algebra, angles on parallel lines and algebra. So we need to be spotting now some of the rules that we know about angles on parallel lines. There's one line that crosses through here, and these angles both sit on that line and the parallel. So we can link these two angles in a couple of different ways. So the first thing to spot is that, and look out for, if angles are on parallel lines like this, that are just across one transversal, then if they look the same, then they are the same. So we could either start from the bottom here and think, okay, well, that one there looks the same as the one above it. And in fact, it is the same. And the reason that's the same is because these two are vertically opposite. Now they are sitting vertically here, but sometimes they don't. Sometimes they sit horizontal to each other, but they're still called vertically opposite angles. And you have to give that actual word, that actual term there. Vertically opposite angles are equal to each other. So that's the first reason you'd write down. Always try and get the reasons out. If there's nothing on here that says show a reason, which is unusual, then let's just go for the maths. But it's good to think about writing it down so you know you're doing the right thing. So this is the same as this. And now look, this angle here, okay, let's just highlight it. This angle here, okay, that's an obtuse angle. And here on the parallel lines, that's obtuse. And look, they look the same. They are the same. They're exactly the same. The other way we could start this is by thinking about, if you didn't spot that vertically opposite bit, there's also what we know as, sometimes it's called an F angle. You could never get a mark for saying F angle, but there's an F shape there. Oops, just about. You can see a back to front F between this angle here, okay, and this angle here, F angle. Now, that F angle, this is a really weird way of saying it. I say F goes with C, like fish and chips, okay, football club. So F goes with C, and that's a corresponding angle. And so corresponding angles are also equal to each other. Again, if they look the same on parallels, they are the same. So, and then you will see that it actually sits opposite this one, and those two look the same. They are the same as well. So that one there, oops, is equal to the one underneath it, vertically opposite. So there's two reasons there. Another thing you could have with a FC, a corresponding fish and chip. I've said about the big greasy fish and chips. You could slide this angle up to here. It slides into place. Okay, a bit of a silly way of saying it, but some people remember it. So now let's deal with what we've got, deal with the maths. And so those two are equal. This one is equal to the one underneath it, okay? So these two are equal. So let's write that down, okay? 2x, it's plus 15. Set it up, equals 3x minus 38. So I'm literally just writing down what I see. I've now created an equation. I can now solve this equation. So I should be looking to, first of all, get my x's on one side and my numbers on the other side. So I'm always looking at moving the smallest amount of x. Otherwise you end up with minus x's, negative x's, which you can deal with, but it's just a bit of a pain. So we're going to take away 2x from both sides. So colour is really handy. Or you could do like a little bar at the side, or you can put these in circles to show it's your working out. Whatever you do, make sure it's clear that it's your working out. 2x take away 2x, is no x left. I'm left with 15. Take 3x, take away 2x, I'm left with just x, just a single x. You shouldn't really write 1x there, some people do, but it's just left with x, and that means 1x. Okay, so the next part then, we want to get rid of this 38, so we're going to add 38 to both sides, like so. Now, if you need to do a little bit of a calculation at the side, then please do that. Don't try doing it in your head and losing the last mark because you've not been accurate. 8 plus 5 is 13. 3, 4, 5, 53. So we've now ended up with 53 equals x. Okay, now they did ask us to find the value of x. We've done that. But they could also have potentially asked us, okay, well, find x and then work out what size the angle is. So if they've done that, we can now easily substitute our x at 53 and put it into this top one because it's nicer than doing subtraction. Okay, 2 times 53. So I'm just substituting it into what they've given us. 53, sorry, 53. Add 15. Okay, again, don't guess it. 2 times 53, probably do that one in your head. 106, and then add on the 15. Okay, 6, that's 11. Okay, 121. So this angle and this angle and this one and this one, they're all 121 degrees. But it could have been that they asked us, what's the size of the smallest angle on this diagram? And that would be this one here, which is the same as this one here, and this one down here, and this one down here, because all those rules we mentioned before. Now, this angle plus the one we were given in the first place, they actually add up to 180 because they're on a straight line. So I'm just trying to cover all sorts of eventualities here. So this angle here, which is both these bits together, okay, the green bit and this bit, add up to 180. So I'm doing extra questions here, but it's just covering what might have been asked. So on the straight line, it would be angles on a straight line. Okay, on a straight line. Again, getting my reason down. On a straight line. Sum to 180. Okay, sorry about the pen here, it's getting a bit scratchy. Okay, angles on a straight line, sum to 180 degrees. So therefore, if I do, we've just found out this angle here. Okay, so it's either this straight line here or this straight line here. So this angle here is also 121 degrees. We didn't need to find it, but it could be the sort of question you could get asked. Bit of an extension task here, really. So we've got 180. Okay, take away 121. If it had been take away 120, okay, we'd have had 60 left. But take 129, we've got 59 degrees left. So that smaller angle is 59 degrees. They've not asked you any of that on this question, so you wouldn't go ahead and do that as a matter of course, but you could actually be asked that question in an exam. Okay, so on to the next one. So covered that already. So let's just zoom in here. Okay, so another one where you say what you see. Okay, so again, angles in a triangle, 180 degrees. I'm just going to put literally shorthand here because angles in a triangle, you would write the whole words equal 180 degrees. Okay, now that means we've already used 90 up. You don't get a mark for writing 90 degrees. So that means these two, that one plus that one, must equal the balance. That must equal 90 degrees between the two of them. Okay, because you do 180, take away your 90, and you're left with, it just gives our numbers, makes the numbers a little bit smaller to do the rest of the calculation. Get rid of what you know about. Okay, you've ticked that one off. We've got 90 degrees left for these two. So that one plus this one equals 90. I'm going to rewrite that over here. It's always good to give yourself a lot of space for any algebra. So plus 5x plus 18 equals 90. Now this just requires a bit of tidying up. It's all the x's are on the same side, which is nice this time. So we've got 12x. I'm just tidying up, adding those two x's, and the 18 is separate because it's just a number, it's not an x. Okay, equals 90. That's the first task. Second task then is to take away 18 from both sides. Subtract 18 from both sides. Okay, don't guess it, use a subtraction method. to make sure you do it. We could even use a number line to do this one if we wanted to. So take away 18, we're left with 12x here, and 90 take away 18 is 72. Okay, so the last step here is to undo that multiplying by 12 happening there. So we're going to divide by 12 this side, and we're going to divide by 12 this side. So we just get 1x there, because 12 divided by 12 is going to just leave us with 1. And 72 divided by 12 is 6. So x equals 6. So let's look at the question though. Work out the size of the smallest angle. So some people might think, oh, must be this because it's just 5x. But actually, it is actually this one. But we need to prove which one's the smallest. So we need to do substitution again. So we're just going to take our value of 6, and this one here is going to be 7 times 6. So you need to know some times tables here. If you don't know your times tables, then you just need to write out a list of multiples. You can use your fingers if you need to count on, and make sure you get there. So this technique of writing out multiples is brilliant. So you can go step by step. You don't even need to know your tables off by heart, but it just speeds things up if you know your tables off by heart. 36, add on 6 again, is 42, and just so you've got to make sure you've got 48 after that. Okay, so that would have sped the whole process up if you knew times tables. Here, 5 times 6 is 30, so 5 times 6 plus 18, so it's 30 plus 18. So this angle is actually 48 degrees. Now, if you hadn't done both of them, you wouldn't be able to tell which was the smallest. So you have to then obviously you have to then say which is the smallest. So 42 degrees, make sure you've underlined it, that is the smallest angle. And even like that you have to write a sentence. You've shown your answer is the 42. Even if you left it here, I know it's obvious that is smaller, but you've not picked it out. So it might be that you just circle this one, okay, and say that it's the smallest angle. Something to indicate you've done that last bit of comparing and you know it's smaller than 48. Sounds really obvious, but you need to do that sort of thing. Okay, so down to one more. And this one again is about saying what you see. And so this one, if you have your 5x, because you've got 3x plus 2x. Now 3x plus 2x, this is your 90 degrees already done. Okay, so 90 degrees away from this whole point. Now angles around a point, here's another one, not had this one yet, angles around a point. Okay, angles around a point equals 360 degrees. Okay, angles around a point equal 360 degrees. We've used up 90, so it's 360, take away 90. Let's do the calculation for you. So that gives us 0. Oops. 6 take away 9, you can't do it, let's go to 2. 16 take away 9 is 7, and the 2 down. So 270 degrees for this section here. Now, it's worth learning multiples of right angles as well. You could have 90, you've got 180 is 2 right angles, 270 is 3 right angles, and 360 is the 4 right angles, your full circle. So 5x is equal to 270 degrees. Okay, and all we need to do now is a quick divide by 5 on both sides, because we're timesing by 5 here. So we'll divide by 5 there, and we'll divide by 5 there. Let's do that as a quick bus stop over here. Quick practice. 270. Okay, and we've got 5s into 270. Now 5s into 2 don't go, so we haven't used that 2, so we're going to carry that 2 over. 5s into 27 go for 5. And 5 times 5 is 25. We had 27, we've got 2 left over. Now that 2 is a different 2 to this one here. It's because of the 5 times 5 is 25, 2 left over again to carry over. 5 into 20 go 4. That's our answer. So x is equal to 54. Now again, they might ask you, they haven't done, they might ask you what's the size of, you know, this angle here, and all you would do then is substitute and you would do 3 times 54. It's all good practice and a bit of non-calculator methods here. So 54, lined up like this perhaps. 3 4 to 12, 5 3 to 15, 16, 162 degrees on that angle there. So it's about saying what you see, lining it up, and then solving.